In this video, I want to talk about simplifying complex fractions. Now, the name complex fractions is not very appealing, right? But it's really not too bad. So let's first talk about what a complex fraction is. A complex fraction, of course, is a fraction that contains fractions, maybe just one, maybe more. All right, so let's look at an example of a complex fraction and maybe how to simplify it. But before we do that, I'm making an assumption in this video. So the assumption is that you already know how to add, subtract, multiply, and divide rational expressions. Okay? All of those things will be used in simplifying complex fractions. So if you don't know how to do those things, please go refresh and then come back to simplifying complex fractions. Okay, but here are examples of complex fraction. You'll notice that each one has a larger fraction bar, okay? So note a complex fraction has one large fraction bar, okay? So even if it contains other fractions, it's clearly a numerator and a denominator. A numerator and a denominator, and the same thing here, okay? All right, so how do you go about simplifying these things? Well, we're actually going to simplify all three of these. So let's talk about this here, and let me clean this up a little bit so we can talk about it. Now, what we'd like to do is think of each of these fraction bars as division, because then we could just use our techniques for dividing fractions. And in fact, this first one is literally a fraction divided by a fraction. And so when we do this one, you'll see we're going to look at it just as division. This one, though, our goal is to make it into a fraction divided by a fraction. Now, what do I mean by that? What I mean is I want a fraction, a single fraction on top. So our goal is to turn this into a single fraction, divided by a single fraction. So I'd like to turn all of this into a single fraction. And then it will be similar to the first one, where it's just division of two fractions. And this is also true for the last one. I'd like the top to be a single fraction, and I'd like the bottom to also be a single fraction. And then we can just divide. Okay, so maybe we'll do the first one here to see how it works as division, and then we'll work on the next two. So here we want to simplify this complex fraction, one fraction divided by another. So I always like to take the big fraction bar and write it as the division symbol. So now I've got the top fraction, v minus 7 over 2, divided by, right, I changed my fraction bar there to a division, divided by the bottom fraction. And now, I said at the beginning of the video that I'm assuming you know how to divide fractions. Well, the way you do it is you multiply, change it to multiplication. Sorry about that. So I take my first fraction, multiply it by the reciprocal of my second fraction. So I get 8v on top, and on bottom I have v squared minus 14v plus 49. And now all that requires is multiply. Okay, and I'm assuming you know how to do that. So I won't finish here, but you can see how we took a complex fraction and now it's a multiplication problem that we can do. Let's take a look at the setup for the other two problems. So you're thinking, well, this fraction bar is division, so I could do the same thing. I could write the top divided by the bottom. The issue with this problem is that this is not a single fraction. and the bottom is not a single fraction either. So the first thing we're going to do is turn those into individual fractions. So we're going to do that off to the side here. So the first thing I want to do is take my numerator, this entire numerator of the large complex fraction, and work on it. So x minus 22 over x plus 9. I need to subtract these, and so the first thing I'm going to do is turn x, right? X is a fraction, which is x over 1. And instead of minus this fraction, I'm going to change it to plus a negative fraction. I always like to change subtraction to addition. Okay? And then to add these, I need a common denominator. So I have to multiply each fraction by some form of the number 1 to make the denominators the same. So my first fraction, I'm going to multiply by x plus 9 over x plus 9, because then my denominator will be 1 times x plus 9, which is the same thing as the denominator here, which is x plus 9. So my second fraction, I don't really have to multiply by anything, but if I want to write it, I'd say times 1 over 1. All right, then my first fraction becomes x squared plus 9x on top over x plus 9. My second fraction becomes, well, negative 22 on top over x plus 9. And then when I add my numerators, I get x squared plus 9x minus 22, right? That's what I get when I add my numerators together, over my common denominator of x plus 9. And so this that I got here is the same as the numerator over here in the original problem. So I can come back to my original problem, and I can write my numerator as x squared plus 9x minus 22 all over x plus 9. And then that is my numerator. So I still have to work on the denominator down here. Okay, I need to make that a single fraction. I've already changed the two things on top into a single fraction here. Now I need to do the same thing on the bottom. So I'll do that on my side work as well. So there was the first fraction. And then I need to do my second one. So I've got, let's see here. One plus 2 over x plus 9. I'll make 1 into a fraction. I'll leave a space so I can go ahead and write my forms of 1 here to get a common denominator. I'll multiply this guy by x plus 9 over x plus 9. And so my first fraction is x plus 9 over x plus 9, and my second fraction is 2 over x plus 9. And when I add those together, on top I get x plus 11 over my common denominator of x plus 9. So that's what my denominator will be up here in my complex fraction, x plus 11 over x plus 9. All right, so we took the original problem, which was this mess on top over this mess on bottom. Now I've got a fraction on top and a fraction on bottom, so now I can write this as the top fraction divided by the bottom fraction. And then I'll change it to multiplication, and then I'll multiply. Okay? So the goal is to turn a complex fraction into a division problem of two fractions. And so you can see in this problem, to do that, we had to combine the stuff in the yellow on top into a single fraction. We had to combine the stuff in the blue on bottom into a single fraction, and then we could finish it pretty simply. Let's look at the last example. So you can imagine here you've got the same game plan. We need a single fraction on top. We need a single fraction on bottom. So there's going to be a lot of side work here. So let's go off to the side and get busy. I'm going to work on the top first, which is 1. So I'll write that as 1 over 1 and leave a space. Plus 13 over x, leave a space. Plus 42 over x squared. I need them all to have the same denominator, and I multiply each of these by a form of 1. X squared is what is common, a common denominator to all three. So I'll multiply the first one by x squared over x squared, the second one by x over x, And the last one has x squared on bottom, so I'll multiply it by 1 over 1. So that gives me, I've got this guy, which is going to be x squared over x squared, plus this guy, which is going to be 13x over x squared, plus this guy, which will be 42 over x squared. Now they all have the same denominators, so I'll get a single fraction with x squared on bottom, and on top I'll have x squared plus 13x plus 42. So that's going to be my numerator of my complex fraction that I can come over here and put on top. Okay, so that's just the numerator part. Then I've got my large fraction bar for my complex fraction, and I need to figure out what the bottom is going to be now. So I've got 1 over 1, right? I'm working on the denominator now, plus 8 over x plus 28 over x squared. Again, common denominator is x squared, so I'll use my forms of 1 here. And again, if you don't have to write anything on the third one, but if you want to get in the habit, you could put 1 over 1. So this gives us our first fraction. When I multiply, I get x squared over x squared, plus my second fraction is 8x over x squared, plus my third fraction is 28 over x squared. Putting all that together, I get a single fraction with x squared in the denominator, and on top I have x squared plus 8x plus 28. So that will be my denominator of my complex fraction over here. So I'll copy that down to be x squared plus 8x plus 28 over x squared. And now I have a fraction divided by a fraction, so I'll write it as a division problem. X squared plus 13x plus 42 over x squared, the top fraction, divided by the bottom fraction, x squared plus 8x plus 28 over x squared. Now it's a simple division problem. You can finish it from there. So again, the key is we need a single fraction over a single fraction. Why? Why do we need a fraction over a fraction? So we can work it as a division problem. Okay? So that's the key to complex fractions. Now, let me say this. I've taught complex fractions for a long time, and I'm aware that there's another way to do this, and actually, I like the other way a lot. In fact, it's the way I typically do it. The reason I'm presenting this technique is because no matter how many times I've taught the other technique, students always come back to this. They always accidentally try it this way because we're so used to getting a common denominator. So for that reason, I purposely presented it this way in the video, and I think it's a good introduction. There are other techniques out there. You're welcome to try those, but I've not had much luck with it with students. So again, that's why I went with this particular technique. Good luck with complex fractions. Take your time. Make sure you get your common denominators right. Make sure you divide properly, etc. Okay?